Everybody, so we are starting on page 9 in the note packet, and again, you're going to want to have your guided practice blue packet and your purple homework packet handy as well. So folks, we skipped those 3 problems up at the top since those are solving by completing the square, which we are not going to do. So we are going to solve using the quadratic formula. So first, this is what the quadratic formula equation looks like. And the only thing that I don't love about the song is it just starts with the quadratic formula is negative b. Really, we need to have the x equals there. The x equals tells us that what the quadratic formula is giving us are the x-intercepts or the solutions. So we got to have that x equals because that's what the quadratic formula is giving us. B squared minus 4ac is the stuff underneath the square root, but we have a fancy name for it called the discriminant. And what's nice about the discriminant is we can use that to tell us the number and type of roots we will have. So it tells us the number and type of roots. So it tells us the number and type of roots. So we're going to go ahead and take a look at this first problem. Now, we're purely going to be using the quadratic formula on this page. Once we get into the guided practice, we're going to start putting all our different methods of solving together. Should we solve by factoring? Should we try to solve by graphing? Should we try to solve using the quadratic formula? It's going to save us a little bit of time and figure out how to be the most efficient with these problems. Now, first up, with the quadratic formula, just like with solving by factoring and solving by graphing, is we need to be in standard form first, which means it's got to look like ax squared plus bx plus c equals 0. So taking a look at number 1, is that in standard form? Who should we move? The 11. So x squared minus 10x minus 11 equals 0. So now I have my A value, my B value, and my C value. Now, folks, for the quadratic formula, your A value doesn't have to be positive, but it does make simplifying a little bit easier if it is. So what we are going to do first is we're just going to practice writing the quadratic formula. So we're going to start with x equals, quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. There it is. I'm not going to make you write it every single time. What I'm going to be modeling is how I kind of sing the song to myself as I'm filling in the values. So, drawing my A, B, and C values directly from the equation, just like I did with the axis of symmetry, my A value would be 1, my B value would be negative 10, and my C value would be negative 11. So, quadratic formula is negative B, negative 10, plus or minus the square root of b squared, negative 10 squared, don't forget your parentheses, minus 4, or a value of 1, c value of negative 11, all over 2 times 1. If you find it helpful, when your equation's in standard form, you can list what each of those values are. A is 1, b is negative 10, and c is negative 11. If that helps you, you are free to do that. Otherwise, you can just pull those out directly from the equation. So, couple of big things. These parentheses, you got to have them, especially when the number is a negative. If you don't have those parentheses there, your calculator is going to be like, oh, you want the opposite of 10 squared, which is a negative 100, instead of 100, which is what negative 10 times itself is. So those parentheses are a big deal. Second big deal is this negative is a minus sign. B squared minus 4ac. And that is important for how you type it in on your calculator. So folks, we're not going to type in the whole thing. What we start with is actually the discriminant. So we're just going to type the stuff under the square root in on our calculator. So calculators at the ready. And we're not even going to include the square root. We are literally just doing the stuff under the square root as the discriminant. So parentheses, little negative 10, squared, arrow over to escape the exponent, and then minus, big minus sign, 4 times 1 times negative 11. And we get 144 for our discriminant. If you don't think that those things that I mentioned are a big deal, here's what happens if you don't include the parentheses in front of that negative 10. Ooh, a negative number. Pretty different negative number at that. Here's what happens if you use a little negative instead of the minus sign in front of that 4. Oh yeah. So there are some big problems that arise if you don't type it in on your calculator correctly. So working on the parentheses, working on the minus sign, and actually trying it on your calculators yourself today is going to be huge, because if you don't get that discriminant right, the rest of the problem gets pretty horrible. So our correct discriminant was 144. Now I'm going to draw a box around 144 because that is a perfect square. So if I'm not going to end up with anything underneath that square root, what do we know about the types of solutions that we have? If the square root goes away, I've got no chance for irrationals, and I've got no chance for complex or imaginary roots. So my only possibilities are 2 real rational roots. And that's what's cool about the discriminant, is we can actually describe that from the get-go before we actually find what those roots are. So let's go to our next line of work. That negative 10 is going to become a positive 10. And then we've got plus or minus the square root of 144. All over 2. Can I divide that 144 by 2? If I have the square root of 100, actually let's do something simpler. If I have the square root of 9 over 3, what is the square root of 9? 3. So this should give me 1. But if I take a 3 out of here, then I get the square root of 3. Is the square root of 3 the same as 1? No, it is not. So what that means is we cannot divide square root numbers by that 2 on the bottom. So what we need to do next is simplify the square root. This is step 2. Simplify the square root. So step 1 was finding the number under the square root. Step 2 is simplifying the square root. Well, the square root of 144 is 12. So then we get 10 plus or minus 12 divided by 2. Next step, we can use division distribution. 10 divided by 2 is 5, and 12 divided by 2 is 6. So 5 plus or minus 6. So what does this mean? The plus or minus is actually indicative of 2 solutions. One where x is 5 plus 6, and one where x is 5 minus 6. So the plus becomes a solution scenario, and the minus becomes a solution scenario. So I break it up into 2 separate cases. And this gives me my 2 solutions. This simplifies to be 11, and this one simplifies to be -1. And those, I'm going to write them up here. Those are my 2 real rational roots. Real, because we can see them on our graph. Rational, because those are integers. Now, could we have solved that one by graphing? Would I have been able to find those x-intercepts on my graph? Yep, they're exact numbers. What about by factoring? Could I have solved it by factoring? Yeah, and factoring would have been way easier because product of negative 11, sum of negative 10, we could have just done x minus 11 and x plus 1 equals 0 and gone straight to my solutions of positive 11 and negative 1. So folks, again, it's not just about being able to use the quadratic formula. After we have done some practice with it, we are going to figure out how to determine which is our best method to use for solving. So factoring, would that have been easier? Yeah, a whole lot easier, yes. So that was this part we did on the calculator. So you have to do negative 10 in parentheses squared, and then a big minus sign, 4 times 1 times negative 11. So again, folks, practicing the discriminant part is super duper important on these problems. Let's go ahead and take a look at number 2. The first thing we check for is it in standard form? Is it? Yep, sure is. If you want, you can say what your A, B, and C values are. A is 1, B is 8, C is 16. And let's not write the formula this time. Let's just practice putting in those values. Actually, no, let's practice writing it one more time. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. All right, folks. And now we're going to plug in the values. So my B value is negative, or B value is 8, so negative B will be negative 8 plus or minus the square root of B squared. Do I have to have parentheses around that 8? No. When it's positive, the parentheses do not matter, but I tend to put them in out of habit so that I don't forget them when I need them with those negatives. Minus 4, A value of 1, C value of 16. All over 2 times 1. And now we start with the discriminant. So I want you to type this in on your calculator and see what you get for the discriminant, or the stuff under the square root. Careful with your parentheses, careful with the big minus sign, and you should get an easy number. Once you type it in on your calculator, show your calculator screen to someone sitting close by to you. See if you got the same thing. What are we getting, everyone? It's 0. So negative 8 plus or minus the square root of 0 all over 2. So our discriminant is 0. What does that tell me about the number and types of solutions? Well, 0 is technically a perfect square, because what's the square root of 0? 0. So I get negative 8 plus or minus 0 over 2. If I have negative 8 plus 0 and negative 8 minus 0, is that plus or minus 0 really doing anything? No. So when I get 0 for the discriminant, the plus or minus sort of becomes insignificant. So for a discriminant of 0, what we end up getting is 1 rational, we'll add real, 1 real rational root. Because without the square root, we can't have any of that imaginary nonsense. Without the square root, we can't have any of that irrational nonsense. So 1 real rational root when our discriminant is 0. So what is that 1 rational root? How do we simplify this? We divide negative 8 by 2 and we get x equals negative 4. What is special about this x-intercept? Or what is special about the quadratic when it only has one x-intercept? Where's its vertex? At the x-intercept. So here's negative 4. 1, 2, 3, 4. So I know my quadratic is going to have an axis of symmetry through negative 4 and a vertex at negative 4. So folks, remember how I said that if you were having trouble remembering the axis of symmetry formula, the quadratic formula would help us out? When your vertex is the x-intercept, this goes to 0 and the complete right side goes away, and all you're left with is negative b over 2a. Isn't that my equation for the axis of symmetry? It sure is. So if you can remember the quadratic formula song, you've got the axis of symmetry formula nested in there. Actually, we'll circle the x equals 2. So x equals negative b, skip all that stuff in between, all over 2a, and that is your equation for the axis of symmetry. So that relationship between the axis of symmetry and that x-intercept vertex is no coincidence. That's why we have this formula. Folks, we have now done 2 of these. What questions do you have so far, or what calculator questions do you have so far? On your own, see if you can write the quadratic formula itself, just with those a, b, and c values. You can hum to yourself. It's all good. Ouch. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Make sure you've got that x equals there. Now, checking number 3, is that in standard form? Yep, it's good to go there. So now we can start plugging in our values. Quadratic formula is negative b, negative 6, plus or minus the square root, b squared, 6 squared, minus 4, a value of 2, c value of negative 7, all over 2 times 2. Find the discriminant. Simplify that stuff under the square root. It is not very friendly this time. Should be getting something between 50 and 100 for the discriminant. Yes. What'd you get, Duke? 92 is right, folks. Is anybody not getting 92? The parentheses aren't necessary here, but make sure that that is a minus sign and make sure that that is a little negative sign. So we get 92. Now here's the thing with 92. Is 92 a perfect square number? Nope. So here's what I want you to write. 92 is not a perfect square. So we're gonna have square root stuff in our answer. Are we taking the square root of a negative? Is it going to be imaginary stuff? Nope, it's just going to be nasty square root stuff. Will the plus or minus still be there? Yep. So the plus or minus tells me that there will be 2 roots And since we're going to have that square root stuff, we'll have two irrational roots. So step 1, we found the discriminant. Step 2, we're going to have to simplify that square root. So folks, what is the biggest perfect square I can take out of 92? If I were you, I'd probably go, I don't know, Mrs. Cairo, but that's why we have our calculator. Start trying to divide it by perfect squares. It's even, so maybe I'll try dividing it by 4 first. 92 divided by 4 is 23. Sweet. It's divisible by 4. Can I divide 23 by anything? Just 23 and 1. So those are my two factors. The perfect square factor of 4 and the non-perfect square factor of 23. So negative 6 plus or minus square root of 4 square root of 23. Sometimes students get weird about where the plus or minus is and where everything is falling in the problem. All we have done is replaced square root of 92 with those two multiplied together. From here, we simplify the square root of 4 to be 2. So don't try to cancel out that square root of 4 with 4 because we proved on the board that you can't do that. So negative 6 plus or minus 2 radical 23 all over 4. Gross. It looks awful, doesn't it? Can we simplify this? I can do division distribution. What does negative 6 over 4 simplify to be? Negative 3 halves. And then 2 rad 23 over 4. I can cancel out the 2 with the 4 since that 2 is not trapped outside the radical. So negative 3 halves plus or minus radical 23 over 2. Does everyone see what we did there? You could also think of taking a GCF of 2 out of all 3 of those parts, but I think the division distribution is a little bit easier. Now, folks, you could leave your answer like this. But I want to show you what the 2 roots are because sometimes students get confused with the fact that this is a binomial. My 2 roots come from the plus and minus in between these fractions. I take the positive version of this, which would be x equals negative 3 halves plus rad 23 over 2. And then the negative version, which would be x equals negative 3 halves minus rad 23 over 2. Did I find 2 irrational roots? We did. Sometimes students are kind of like, wait, but negative 3 halves is rational. It is, but folks, if I add something rational to something irrational, for example, if I have 2 plus pi, 2 is rational, pi is irrational, but when I add these two together, I get 5.341592654. Isn't that an irrational number 2? Yeah. So it doesn't matter that the negative 3 halves is rational. As soon as I add it to something nasty, like that square root stuff, I get 2 irrational numbers. So this is one root with the plus in between. This is another root with the minus in between. Now, if I were you, I'd be a little skeptical. It's like, really? Those are the roots. That's what I plug into the equation to get 0. I'm going to show you graphically how we can prove this. And if you're like, oh, great, graphing, our favorite thing ever. Go ahead and go to your y equals and type in this equation. 2x squared plus 6x minus 7. We're going to be using our calculator grapher a lot today to help us figure out our best method of solving. Now, what is handy about this is we can use our trace button to verify different inputs. If you think it looks like we have a root at positive 1, you can hit your trace button and just hit the number 1, and it will tell you what that x value of 1 gives us as an output. And what we find is that it gives us a y value of positive 1. So is 1 the x-intercept? No. But I'll tell you what is an x-intercept. This horrible looking irrational number. If I hit trace and type in negative 3 divided by 2 plus square root of 23, and your parentheses to close off the square root, divided by 2, we get exactly 0. Isn't this what we wanted that whole time in the table? We wanted a number and 0. That horrible looking number is the real deal. That's what gives us the y value of 0. And if we trace this other value, that should give us the left x-intercept. Let's try it. Negative 3 divided by 2 minus square root of 23, close off your parenthesis, divided by 2, bam. There's my other x-intercept. So it works exactly. It's a non-terminating, non-repeating decimal, but those are the two solutions of my quadratic exactly. What's nice is, with these calculators, you're going to be able to check yourself and make sure that you've done all that quadratic formula stuff correctly. Your calculator won't catch if you've simplified the radicals correctly or the square roots, but you will be able to check mathematically if your roots are the real deal. So trace button is how we engage our x equals, and if I just hit the number 8, that will give me the output for that x input. I hit 6, it gives me that output. Negative 2, it gives me that output. So trace allows you to type in an input, and your calculator will show you the xy pair for that input. Folks, how are we doing so far? I want you to get as far as you can on number 4, taking note that that one is not in standard form. Practice writing the formula, practice writing in those values, and see how far you can get with finding the discriminant.
Mrs. Kyra, can you look at my calculator?
Yeah.
It's like every time I calculate, just replace it.
So it'd be 2, oops, so 2, caret, no, 2, then the x button, and then you need to make it to the power of 2, so that's what that little number is, so you just had 2x2, there's that one, and then what was the rest of the expression? Plus 6x minus 7,
Yeah.
so plus 6x. Is anyone else having calculator issues?
Miss Kyra?
Hmm? So you're going to type C extension into that spot, and then once you have the graph, then you hit trace, and that's where you type in all your tabs there. So you'll have the original quadratic and your equation equals, and then trace for your All right, standard form first. X squared minus 6x plus 10 equals 0. Quadratic formula is negative b, negative 6 plus or minus the square root b squared, don't forget your parentheses, minus 4ac all over 2a. So again, on your calculator for the discriminant, make sure you've got the parentheses then little negative 6 squared, big minus sign 4 times 1 times 10. And what we find is that our discriminant is negative 4. When I get a negative under the square root, what does that automatically tell me about the solutions? They are going to be imaginary. So my discriminant is negative, and negative under the square root means I. So we would say 2 imaginary or 2 complex roots. So now to simplify this, after we've calculated the discriminant, we simplify the square root itself. So what is the square root of negative 4? 2i. From here, division distribution. 6 divided by 2 is 3. 2i divided by 2 is 1i or just I. So folks, we can write our roots like this, but just note that those two solutions would be 3 plus I and 3 minus I. The two roots come from the plus or minus aspect of it. It's not that 3 is one root and I is the other root. It's the positive and negative versions that give us the two roots. Now, folks, if I type in that equation, what am I going to see for x-intercepts? If they're imaginary, what's my calculator going to show? It's going to go, guess what? Graph doesn't touch the x-axis. That's because the imaginary roots are not real. So they're imaginary solutions, but they don't show up as real x-intercepts on our graph. All right, folks, we're going to take a bathroom break, phone break, before we move into the guided practice.